So this video will be on ethers and esters. I decided to put these two together because it's important to see the difference between them. So an ether, the functional group you're looking for is a COC. So it's in the middle of a carbon chain. There's an oxygen molecule. And when you're naming that, you want to put oxy after the side chain, so the shorter carbon molecule, and then follow that by naming the larger carbon molecule or the larger carbon chain. We'll start with example 1. So I can see my larger carbon chain will be 1, 2, 3, 4 carbons long. So that's a butane. And I name my side chain as the methyl. And instead of the YL, it will get the oxy because this replaces the YL as the oxygen molecule, because now it's a meth-oxy chain. The second example down here, now the methoxy group is off of carbon number 2 on a hexane chain. And we also have a chloro side chain. So you still start the numbering with alphabetical order. It's going to be the 5-chloro first, followed by the 2-methoxy, so the methyl with the oxygen, and then hexane as the side or the full backbone name. This example includes a benzene molecule, a 6-carbon ring with a delocalized 3 double bonds as this oxygen. Sorry, not an oxygen, as this ring of delocalized electrons. So that's the benzene is going to be the backbone in this molecule. And this will be a 1, 2, 3 carbon oxy side chain, which will be propoxy. Following that with the benzene. So we've worked up harder and harder to this final example on the right. Which is a little more difficult with these hydroxy side chains as well as the oxy as the ether side chain. And we have those 2 hydroxys. So we'll number the carbons on the backbone so that the oxy gets the lower number. And that'll be a 1 here, 2, so that'll be a 3 with that oxygen ether side chain. 4, 5, 6, 7, so it's an 8 carbon long backbone, which will be octane. And then I'm deciding, does a 1,4 dihydroxy go before a 3, 1, 2, which it would be a F3-ethoxy. And by alphabetical order, and with the numerical 1 winning, the 1,4 will go in front. So I think in our class we'll call it a 1,4 first. Dihydroxy, and then follow that with the 3-ethoxy. So that the numerical 1 wins. So the full name is 1,4 dihydroxy 3-ethoxy octane for that molecule. So esters are different from ethers in that the carbon that is attached to the oxygen, in between one of those carbons on either side, there's a carbonyl. So this one goes a carbon chain, a carbon with a C double bond O, and then also attached singly bond to another oxygen followed by another carbon chain. And in this, the naming is oate that you're going to follow at the end of the backbone of the molecule. And the backbone of the molecule is already decided for you in this one. It's not numerical, which one wins, which side chain is bigger. It starts always on the carbon that includes the carbonyl. So this will always be carbon number 1, and I can't cross over the oxygen to continue numbering. I continue numbering left to name that 2. So in this first example, the backbone is ethanoate. An for single bonds, O8 for the carbonyl ester bond. And then I just have to name this side chain as propyl for 1, 2, 3 carbons. The next example, my backbone is again here. The carbon with the carbonyl bond is numbered 1 and 2. So this is another ethanoate. And this time our side chain is a benzyl. I just wanted to show you this example because it's another one that you need to know. And the common name for this one, which I don't think you need to know, I'm going to say no, just for FYI, is benzyl acetate. Just to show, again, the benzene molecule, you want to identify that as soon as you see a 6-carbon ring with that delocalized electron ring in the middle. The following example, I'm going to name this as my backbone and numbering that carbon 1, but it goes 1, 2, 3, 4. So monkeys eat peeled bananas, that's a bute. An and O8, whoops. And then I have a methyl. I don't say methoxy here, even though I am encircling the oxygen with that side chain. I shouldn't be. I should be circling the oxygen with the ester as the O8, because the whole functional group is the C double bonded to the O as well as the single bond to another oxygen atom. So I'll do better this next example. This next example is again the crazy version, but we'll just do it step by step. So start numbering your backbone. It'll be 1, 2, 3, 4. And off of my backbone, I have a 2-chloro. So I'm going to start from the end and start with a 2-chlorobutane for the finish of my name. And then I start, oh, sorry, that's wrong. It should be butane O8 because that backbone includes the ester bond, OAT. So now I can number my side chain. It'll be a 1, 2, 3, 4, 5 carbon side chain, and I'll start that with a pentyl, YL for the side chain alkane groups. And off of that side chain, I notice another substituent, which is a 3-bromo. So the full name for that molecule is a 3-bromo pentyl 2-chlorobutanoate.